Alright everyone, let's chat about two important concepts, simple linear regression and logistic regression. Think of simple linear regression as our go-to when we want to predict a number. Imagine you're trying to figure out how many hours you need to study to get a certain grade. Your study hour is the predictor or independent variable, and your potential grade is the number we're trying to predict or the dependent variable. Simple linear regression helps us draw a line that best fits the data points, so we can say, for every extra hour you study, your grade might go up by, say, 5 points. It's all about that straight line relationship and predicting a value on a continuous scale. The equation for simple linear regression says that the predicted value or y hat is equal to beta sub 0, our starting point or intercept, plus beta sub 1, our slope, the rate of change, multiplied by x, our input variable. Where y hat is our predicted number, like your exam score, x is our input variable like study hours, and beta 0 and beta 1 are the magic numbers of the intercept and slope that define our line. Now, let's switch gears to logistic regression. This is where things get interesting because instead of predicting a number, we're trying to predict a category, specifically, a category with just two options. Think of it as a yes or no, a pass or fail. Let's say I want to predict whether you'll pass or fail that exam based on your study hours. Pass or fail isn't a continuous number, it's a category. This is where logistic regression shines. Instead of giving us a direct grade, it gives us the probability of you belonging to one of those categories, for example, the probability of you passing the exam. The equation for logistic regression states that the probability of y being equal to 1, given our input x, is equal to 1 divided by 1 plus e to the power of negative, beta sub 0 plus beta sub 1 times x. This mathematical formula squishes our prediction into a probability, a value between 0 and 1. This is the probability of our outcome being in the 1 category, pass, given our input, study hours, x. The e is a mathematical constant, and the part in the exponent, beta 0 plus beta 1 x, is pretty similar to our linear regression equation. So, what's the big takeaway? Simple linear regression predicts a number or continuous, while logistic regression predicts the probability of belonging to a category, which is binary. The output, linear regression, gives us a predicted value directly. Logistic regression gives us a probability, which we then usually use a cutoff like 0.5 to decide which category we think the outcome falls into. The relationship in linear regression assumes a straight line relationship. Logistic regression uses a special S-shaped curve or the sigmoid curve to model the probability. We'll dive deeper into how to interpret those beta coefficients in logistic regression in another video. Thanks for watching my video.